What do we know about how demand responds to the change in price? Well, first of all, we know that it decreases. So if the price goes up, then the quantity demanded is going to go down. This is what the law of demand tells us. But is there a nice way to summarize how much that demand is going to decrease? Elasticity is what tells us that. What elasticity is the percentage change of demand per percentage change in price. So if there's a 1% change in the price, how much is the demand going to change as a percentage? Now, the percentage change in demand is, of course, the change in demand divided by the total demand times 100. The percentage change in the price is the change in the price divided by price times 100. Now the hundreds cancel out. And so we've got the change in quantity divided by change in price divided by price. If those changes become very, very small, then that's when we use calculus, right? So we've got change in quantity divided by change in price times price over quantity. That's how we can rearrange this expression. Now, as these changes, we typically use this triangle is the capital Greek letter delta, and we typically use that to represent change. As that change gets very, very small, and we take the ratio of those changes, we get the derivative. So the derivative of quantity with respect to price times price divided by quantity is elasticity. So for example, if elasticity is -2, then what that says is that if you have a 1% increase to the price, then you have a -2% increase to the demand. What's a -2% increase? Well, -2% is a 2% decrease. So how do we calculate elasticity? So let's suppose we had this very simple linear demand function. So the quantity demanded is some number A minus B times P. Well, the elasticity, remember, is the derivative of quantity with respect to price times price divided by quantity. So if we take the derivative of this with respect to price, A is a constant, and so we get the derivative of minus B times P, which is just minus B. So elasticity is minus B times P over Q. If we go back to the example that we had looked at earlier, for pork, the expression for demand was 286 minus 20 times P. So in that case, A would be 286, B would be 20. So at the price P of $3.30 and quantity Q of 220, elasticity would be minus 20, which is B, minus B, times P over Q. 3.3 divided by 220. So we get elasticity of minus 0.3. So what happens to elasticity as we move along the demand curve? As we saw, the elasticity depends on P and Q. So if we move along the demand curve, P and Q are going to change, so the elasticity is going to change. For example, if the price is 0, then elasticity has to be 0 because the numerator is 0. So we say in this case that demand is perfectly elastic, right? So if you have a decrease in the price, then there's no change to demand. If Q is 0, we find that the elasticity is negative infinity. So the demand is perfectly elastic. So think of a situation where the price is high enough that there's a very small quantity of the good being demanded. If you increase the price just a little bit, the quantity drops to 0. So the proportionate change to quantity is infinite. So moving between the two extreme points, where price is 0 and where quantity is 0, you have every possible value of elasticity between 0 and negative infinity. When elasticity is exactly equal to -1, we say that this is unitary elasticity. So the percentage change in demand is exactly equal to the percentage change in price. So for our particular example with the linear utility function, so when Q equals A minus B times P, that's going to happen at the price A over 2B and the quantity Q equals A over 2. If elasticity is less than -1, in other words, the absolute value of elasticity is greater than 1, then the percentage change to demand is greater than the percentage change to price. So this is going to happen to the left of unitary elasticity. So for quantities that are lower than unitary elasticity, so quantities that are smaller than A over 2. Now demand is inelastic when the elasticity is greater than -1. In other words, when the absolute value of elasticity is smaller than 1. So the response to demand as percentage is less than the percentage change in price. So this is going to happen for quantities greater than A over 2 for this particular demand function that we'd seen. So in other words, it's going to happen to the right of where you have unitary elasticity. So if we draw the linear demand curve, then we see that when the price is A over 2B and quantity is A over 2, we have unitary elasticity. To the right, we have inelastic demand, and to the left, we have elastic demand. So at this corner right here, we have perfectly inelastic demand, and at this corner right here, we have perfectly elastic demand. Okay, is it possible that elasticity could just be constant? So for that particular example that we had seen previously, when Q equals A minus B times P, we saw that you get all the different values of elasticity between 0 and negative infinity. But is that always the case? Is it possible that you just have a fixed elasticity? And the answer is yes. Look at this demand function, A times P to the epsilon. The elasticity of this demand function is always going to be epsilon. It doesn't matter what P and Q are. So to see that, take the derivative of this with respect to, so take dq dp. Well, that's just going to be epsilon times A P to the epsilon minus 1, which is just epsilon A times P divided by P. So this is equivalent to that, but that's just epsilon times, remember this is just Q. If you want to calculate the elasticity, it's just dq dp times P over Q, which is epsilon Q over P times P over Q. The P's cancel out, the Q's cancel out, so we just end up with epsilon. So the elasticity for this particular demand function is always epsilon, and it doesn't matter what P and Q are. Now, some special cases are where the demand curve is a horizontal line. If the demand curve is a horizontal line, so there's your P, Q, demand curve is a horizontal line, then demand is perfectly elastic everywhere. Right? So if that's your demand curve, then any change to the price, if the price changes just a little bit from this particular price, you're going to demand 0. As soon as the price goes up just a touch, even teeny tiny increase to the price is going to cause you to, from demanding, let's say, this quantity to demanding 0. Right? And this is going to happen when a good has a perfect substitute. So if there are two different goods and they had, you'd be indifferent between buying the two goods if they had the same price, if they're identical from your perspective, they're perfect substitutes. Now, if the price of one of them goes up just a touch, you're just going to buy the other one. And so you're going to stop buying the first good. So in this case, you'd have perfectly elastic demand. You could also have a situation where you have a vertical demand curve. So think of a situation where this good is essential. So you can't survive without this good. Well, then you're always you need exactly, let's say, Q star units of this good. And if you don't consume these Q star units, let's say you'll die. Then it doesn't matter what the price is, you're always going to demand this quantity. So the percentage change in quantity in response to some percentage change in price is always going to be 0. So your demand is always going to be inelastic no matter what the price is.